Now we've finished with work on quadratics and we're going to start a new topic. We're going to look at inequalities and simultaneous equations. So in this video we're going to talk about linear inequalities. And these are the four different signs you get when dealing with inequalities. And the meanings of them: this one's greater than, less than, greater than or equal to, less than or equal to. So we could write down something like x is greater than 10. Now notice how some numbers satisfy this inequality for x and some numbers don't. Like numbers like 2 or 7 wouldn't satisfy that because they're less than 10. But any number that's bigger than 10, say something like 15 or 28 or anything like that, that's bigger than 10, would be a solution. So unlike just a linear equation, linear inequalities have a set of solutions rather than just one value of x that's allowed. And we solve linear inequalities the same way as we solve linear equations. But the one important thing to remember is, if you multiply or divide by 0, you reverse the inequality sign. So let's look at some examples. First one's going to be 2x plus 4 is less than 13. So I'm going to do it the same way as we do equations. I'm going to subtract 4 from both sides, so I'm going to get 9. And then I'm going to divide both sides by 2, so I get x is less than 9 halves, or if you like, 4.5. So any number less than 4.5 would satisfy that inequality. Next example is going to be 7 minus 3x is greater than 10. Now first thing I'm going to do is I'm going to subtract 7 from both sides, so I get minus 3x is greater than 3. And now what I have to do is I have to divide both sides by minus 3. Now this is where you have to be careful. We're getting x here, we reverse the sign, so now it's facing the opposite direction. Minus 3 and 3, that's minus 1. So any number less than minus 1 would do it. And to check that, you can simply put numbers in to the expression and you'll see that they satisfy it. Any number of x that's less than 1. See, we could put 2 in here. Minus 2 in here. And notice what we get is 7 plus 6, which is 13. And we know that 13 is greater than 10. So numbers less than minus 1 do satisfy it. Now we're going to look at a real life problem with inequalities. We've got a rectangle with these two dimensions, 2x plus 3 meters and 5x minus 4 meters. And we want the perimeter to be less than 40 meters. What we could do is we could look at these inequalities both separately. Now, we'll look at the perimeter first. And the perimeter for that's going to be 2 times this dimension plus 2 times the other dimension. And we want that less than 40. So we can simplify that a bit. I get 4x plus 6 plus 10x minus 8 is less than 40. And then we can combine some of this, and I get 14x minus 2 is less than 40. And then I can add 2 to both sides, and I get 14x is less than 42. And then divide both sides by 14, I get x is less than 3. So, less than 3 is very good, but notice we've got another inequality here. And you know that we can't have lengths that are less than 0. So, this inequality 5x minus 4 must be greater than 0. So let's have a look at that. So we can solve that. I get 5x is greater than 4. And then I divide both sides here by 5, and I get x is greater than 4/5. So notice we've got 2 conditions here. X has to be less than 3, but also so this length here isn't negative, because we're not allowed a negative length. X has to be greater than 4/5, because you know that if it's not, then that would turn out to be minus, which isn't allowed. So these are our 2 conditions here, and it has to satisfy them both at the same time. So I can rewrite that like this. X is greater than 4/5 and less than 3. So that means x lies within this range. It means the set of solutions is in between 4/5 and 3. Because this here can't be negative number. Otherwise, any x less than 3 would be a solution. But common sense tells us that negative lengths aren't allowed.